Online students, can you hear me clearly? Online students, can you hear me clearly? Okay, thank you. Okay, I'll wait like few minutes until everyone joins. Uh, okay, I'll take like a few minutes. I mean, before starting coplanar forces, I'll take like 10 minutes to revise a small point, not actually revise. Actually, like a point that I missed last week from Newton's laws. I did that for the Sunday class students. I did that for the Saturday class students too. I wasn't able to do that for the Thursday class students, so I'll quickly go through that. It's practical related to friction. Will take 5 minutes. Okay, I will take 5 minutes, and I'll first try to finish that. Okay, I'll take 5 minutes and try to finish that area. Then I think by then everyone will be there online available. So then I can start the discussion for today with coplanar forces. So the thing is this practical. Okay, thing is this practical. There's a small practical in Newton's laws lesson. This is not actual practical. An actual practical in the sense you have a practical guide, right? You have a practical guide, an official practical guide. This is not available in the actual practical guide, but this is a small theorem that they use to like show how some theorems work. Okay, there are some practicals that they used in the class to show how some theorem works. Okay, so the idea is like we place a w naught mass here, and we place a mass w on that. Then through a string we place a plate like this, and the mass of the plate is m naught. Mass of the plate is m naught, and we'll keep a mass of, we'll put a mass of capital M onto this. So the total weight of this part would be m plus m naught. The total mass here, capital M. So the total weight here is m plus m naught g. Total weight here is W plus W naught G. W plus W naught G. So as usual, the normal reaction here would be equal to the same thing, W plus W naught G. And here you have a tension, and under equilibrium, this tension is equal to, m plus m naught g. For the students who join late, I still haven't started coplanar forces. I'll start coplanar forces within 5 minutes. Until everyone joins, I'm doing a small practical related to friction, which is not an official practical. Okay, so if the weight here is m plus m naught g, then the tension here is equal to m plus m naught g, right? If the weight here is m plus m naught g, definitely the tension here will be equal to m plus m naught g. Clear? Then the same tension will continue until this point. Clear? Same tension will continue until this point. Clear? Who balance this tension? The friction balanced balance this tension, right? Backward friction balance this tension, right? You have a tension here, it is there's a weight here, that weight is balanced by this tension, clear? That tension continues until here, and this tension is balanced by friction, clear? So in this practical, what we do is we place a certain mass here, and we add mass onto this, we add mass onto this, until this suddenly moves, clear? When does this suddenly moves? When the friction is equal to the limiting friction, right? This suddenly slips, okay? This suddenly slips, okay? When the friction is equal to the limiting friction, clear? When the friction is equal to the limiting friction. And limiting friction is equal to mu r. Limiting friction is equal to mu r, clear? So here, tension is equal to m plus m naught g. Tension is equal to m plus m naught g, and again tension is equal to, here tension is equal to limiting friction equal to mu r, and mu r equals to, mu, and r is this w plus w naught g, clear? You have the weight here, m plus m naught g. It continues until here, which is equal to the limiting friction. And limiting friction equals mu r. Mu r equals mu into r is w plus w naught g. Clear? R is w plus w naught g. Clear? So, here we have these. I'll use this one and this one. Mu w plus w naught g equals m plus m naught g. G and G will cancel out. G and G will cancel out. I can write m plus m naught equals mu w plus mu w naught. Okay? Then I can write something like this. Then I can write m equals mu w plus mu w naught minus m naught. Clear? M equals mu w plus mu w naught minus m naught. Clear? This is a y equals mx plus c graph. Can you see? This is a y equals mx plus c graph. Okay? So what we do here is, we do a practical by changing w and m. We do a practical by changing w and m. Clear? That means I add a certain mass, I place a certain weight here, mass here, and until it slips, I keep adding mass here. Clear? Then I know the w value, I know the mass I added here. Using these two values, I'll mark a point with the proper w and m. Clear? I'll add another w here. For new w, I'll mark m. For another w, I'll mark m. Like that, I will get a series of points. Okay? Like that, I will get a series of points. Clear? By changing w and m. Then I will draw a general graph like this. Okay? I'll choose the best graph that I can draw and I'll draw that. Okay? And what is the gradient of this graph? Mu, friction coefficient. See? What is the gradient of this graph? Mu, friction coefficient. Clear? That means we can get the friction coefficient, okay, we can get the friction coefficient using this graph, clear? That is the idea. This is a practical that we use to show the friction coefficient, clear? To find the friction coefficient. And again, we can use this to prove different stuff. By this, we can prove, okay, W with W M increases. What is the meaning of that? With W M increases, what is the meaning of that? That means friction increases with normal reaction. Friction increases with normal reaction. And we know friction does not depend on the area, right? We know that the friction does not depend on the surface area, right? So we can prove that by placing different sides of this block. Assume that this is a block like this, not a uniform block, a block like this. See? So if it is a block like this, you have a smaller area. You first place that small area here. Next you place this area here. Okay, like that you change the area that touches the ground, okay, and keep doing the practical, and you show that you are getting the same answer. Meaning of that is area does not decide the friction. We know that from all levels, right? And I have explained why. Area does not decide the friction. Clear? That is one thing. Again, we can show how the surface, nature of the surface decides the friction. How? We can use some rough papers of different gauges. We paste one rough paper here, do the practical. Then we paste another rough paper here, do the practical. We paste another rough paper here, do the practical. Then we show when the surface changes, friction changes. Okay, like that. This is not an official practical included in the syllabus, but this is a practical that we use to show the behavior of friction under different scenarios. Clear? How friction responds to different scenarios. Got the idea? Clear? That is the idea. And at the same time, you can do a similar practical like this. Instead of using blocks and this, you can simply place the object like this and use a Newton balance. Okay, it is way more simple. It is way more simple, right? You just use a Newton balance. You keep pulling it until this starts moving. Then you get the reading. Okay, this is another method to do the practical. Okay, instead of going through all this trouble, you just place the block here. You connect a Newton balance to that. Newton balance will show the force. You just pull it. You just pull it until you get a reading. Clear? Until you get a reading. Clear? You just pull it until you get a you just pull it until this starts slipping. You pull it until this starts slipping, and when it slips, you get the reading. Okay, like that you can easily get the readings. Okay, so that is the practical. Okay, that is the practical. Okay, so let's go to the lesson today. Let's go to the lesson today. Coplanar forces. ඒක තලබල. Let's go to the lesson. Coplanar forces. Okay. Let's continue to the lesson today. And the reason we decided to move online is there's a huge rally next to this, but it seems like our soundproofing is better. We hear nothing from that here, right? So we should have done the class physically. Anyways, let's continue. We should have done the class physically actually. There's no actual disturbance from them. At the moment, at least. That's why I mean, yesterday night we get to know that, so that's why we informed that let's do the class online for today. But actually we should have done it physically. There's no actual disturbance due to the soundproof. Okay. Okay. Uh, Coplanar forces. Today's lesson is coplanar forces. That means coplanar forces is a lesson that we already know, okay? That means we are talking about equilibrium, okay? We are talking about equilibrium, and a lot of stuff about equilibrium you already know, okay? Lot of stuff about equilibrium. Lot of stuff about equilibrium you already know. Why? Why? Uh, Talking about the equilibrium, like you already know that how things work, and I mean, what are the conditions for equilibrium under two forces, you already know, right? What are the conditions for equilibrium under three forces? Still, you already know, right? Okay. From O levels, can you remember? In O levels, you knew about equilibrium, right? From O levels, you knew about equilibrium. You knew how the equilibrium behaves under two forces, how the equilibrium behaves under three forces. Okay, we discussed about equilibrium, right? So this, in this coplanar forces, we mainly discuss about equilibrium and how we lose equilibrium. Okay, but in O levels we discussed about linear equilibrium only, right? Mostly. That means how to place stay, how to like, how to place a, how to keep an object under stationary conditions continuously. We didn't discuss about rotations. Clear? In this lesson, we are going to discuss that too. Okay, that means we are going to discuss rotations and what creates rotations too. Okay, moments actually, moments, how moments behave. Okay, that also we are going to discuss. Okay, so like initial part of the tute, I'm not gonna discuss some content from beginning because uh, like it was exactly there in vectors lesson, right? Triangle of vectors. I have mentioned that in the tute, in the first part of the tute, because I mean, I felt like if you are not comfortable with vectors, you should go through these questions again. And in the beginning of the tute, in the initial part of the tute, you have the exact same questions that you saw in the vectors lesson, okay? And exact same laws. What are these exact same laws? One is vector triangular law, but in this lesson we call it force triangular law. Okay, Mali put the tute in the Zoom chat. Okay, we call it, in this lesson we call it, in this lesson we call it force triangular law. Nothing new. In vectors lesson, it was, we were discussing about all the vectors, right? In vectors lesson, we were concerned about all the vectors, right? But in this lesson, we are concerned about forces. So vector triangular law, in this lesson, we call it force triangular law. Nothing new. Does the law change? No. Law does not change, right? What is force triangular law? If you have one force like this, F1, if you have another force like this, F2, you can get the resultant of these two forces. You can get the resultant of these two forces by drawing the first force, F1, and from where it stops by drawing the second force, F2, from where it stops by drawing the second force F2, first force F1, and from where it stops, draw the second force F2. Clear? Then we complete this diagram, and it gives us F1 plus F2. Clear? F1 plus F2. Clear? F1 and F2, and we get the resultant as F1 plus F2. Clear? Okay. This is vector triangular law. Okay. And another reason to decide to like do the class today online was like considering the safety, because there will be a lot of people there and all, but it looks like we have more people in our class. Okay. So this is vector triangular law. Okay. Okay. Vector triangular law. Okay. We not actually vector triangular law, force triangular law. Force triangular law. Okay. So next one. Next one. Vector polygon law. But in this lesson we call that force polygon law. Okay. Nothing complex. Instead of vector polygon, we call that force polygon. Polygon of forces. What is polygon of forces? You have multiple forces, F1, F2, F3, F4. You have multiple forces like this. Clear? You have multiple forces like this. You first draw F1. You first draw F1. Then you draw F2. Then you draw F2. Then you draw F3. Then you draw F3. Then you draw F4. You draw these four forces, F1, F2, F3, and F4. Clear? And this is the beginning of the polygon. This is the end of the polygon. Now you draw a line from the beginning of the polygon to the end of the polygon. Clear? Now you draw a line from the beginning of the polygon to the end of the polygon. It gives you the resultant. Clear? It gives you the resultant. Clear? You draw a line from the beginning of the polygon to the end of the polygon, and this gives you the resultant. Clear? It's like that. Okay? It gives you the resultant force. In vectors lesson, it gave us the resultant vector. Now we are getting the resultant force. That is the idea. Okay? That is the only difference here. Clear? We are getting the resultant force. Clear? So not going to do the questions, but what you should do is, if you are a new student or a student who missed vectors from any class, if you haven't done vectors, if you are not familiar with these equations, you should like mention that in the Zoom chat, or just send a message to this one at least, not 70154 6825. Send a message to this number at least, not 701546825. At least send a message to this number. At least send a message to this number. Like, then like we'll send you the required recordings. Okay, we'll send you the required recordings from those areas. Okay. Otherwise, anyone who have finished vectors from any class should know this. Okay. Anyone who have covered vectors from any class should know this. Okay. So the next one, and some students joined late, but no big issue. We are still discussing vector triangular law and vector polygon law, things that you already know. Okay. Vector triangular law and vector polygon law, things you already know from the lesson vectors. Okay. Okay, anyone who covered like vectors from any class would know this. Then the next one is vector parallelogram. Again, you know, okay, parallelogram of vectors, you already know this. What is this? If you have a force F1 and force F2, you complete a parallelogram by them. You complete a parallelogram by them. Okay. Then this diagonal will give you the resultant. Clear? This diagonal will give you the resultant. Clear? This is F1, this is F2. Then this diagonal will give you the resultant. Clear? Then again, after that, the equation. There's another equation to get the resultant of two vectors, right? Can you remember that? There's an equation that we use to get the resultant of two vectors that we derived using the vector parallelogram, right? What is that? R squared equals F1 squared plus F2 squared. F2 squared, this angle between F1 and F2 is theta. So R squared equals F1 squared plus F2 squared plus F1 F2 cos theta. F1 F2 cos theta. Clear? Okay. Yeah, 2. We have a 2 there, right? Yeah, thank you. 2 F1 F2 cos theta. 2 F1 F2 cos theta. Okay, F1 squared plus F2 squared plus 2 F1 F2 cos theta. Clear? And again, the angle between F1 and alpha, how did we get that? Tan alpha equals tan alpha equals F2 sin theta, F2 sin theta over F1 plus F2 cos theta. F1 plus F2 cos theta. Can you remember this? Yep. So these were the theorems we learned about vectors. And if there's anyone who haven't learned these areas, there's another option available. You have the mechanics from beginning sessions happening. We provide all the information in our groups. We do that every week. Okay, we do that every week on Sunday evenings. Okay, we do that every week on Sunday evenings. Actually Sunday 9 to 11 mechanics from beginning. From that also you can learn these missed parts. Okay, from that also if you need you can learn any missed parts that you missed in mechanics. Okay, so this is the vector parallelogram law. This is the equations we got using the vector parallelogram law. Clear? Okay, now only we are starting new content. Okay, now only we are starting new content, and there's a practical. We have to start with a practical in this lesson. Okay, we have to start the class with a practical. Okay, we have to start with a practical. Usually I do practicals towards the end of a lesson, but the reason I'm doing this practical today is this is the only or the first official practical that you will see before your first term test. Okay, this will be the, for many government schools, this will be the only and the first official practical. Official practical means the practicals you have in your practical guidebook. This is the first official practical that you will see in your practical guidebook. Okay, so that practical is proving the concept of parallelogram of forces. Clear? Proving the concept of parallelogram of forces. Clear? What is that? What is the concept of parallelogram of forces? You already know. You already know. Which is if you have one force F1 like this, another force F2 like this, you can draw, you can place F1, you can draw F1 and F2 as two sides, of a, you can draw F1 and F2 as two sides of a parallelogram. Then you complete this. Then you complete this parallelogram. Then by the diagonal of this parallelogram, you will get the resultant. By the diagonal of this parallelogram, you will get the resultant. Clear? You will get the resultant by the diagonal of this parallelogram. Clear? That is the idea. This is the parallelogram law. Okay. So how are we going to prove this? There's an official practical in the syllabus. What we do is we take there's a board in the lab. Usually you can see this board in the lab. There's a drawing board like this. There's a drawing board like this in the lab. And it has pulleys connected to that. It has pulleys connected to it. Two pulleys connected to it. We create a system like this. What we first do in this practical is, behind this we paste a white piece of paper. We connect a white piece of paper using 4 pins to this board. Using 4 pins, we connect this paper to the board. Okay. Then we place this something like this. Through these pulleys, we place some plates like this. We place some plates like this. We place some plates like this. Clear? Now what we are going to do is, first what we are going to do is we are going to prove vector parallelogram law. So usually this is a huge board and we paste a big paper behind that. Okay, like this. We place a big paper behind this. Okay, using 4 or few pins. Now what we are going to do is, in this we will place some weight here, another weight here, and another weight here. Okay, I'll call this weight P. Ideally this weight P should be the weight of this and the weight of the plate. Okay, sometimes we only know the weight of this and it is a small error in the practical. Okay, ideally we should know the whole weight here. Okay, whole weight here. Clear? And the weight here is Q. Weight here is Q. And this weight also I know, and that weight is weight R. Weight R. Clear? This is weight P, this is weight Q, and this is weight R. Okay? This is weight R. Now, what happens in this system is, now this is under equilibrium, right? I can keep this system like this under equilibrium, right? Okay. That means these forces are there under equilibrium. Nothing moves. I'll wait until everything becomes stationary. When you put a system like this through these pulleys, they will move here and there like this. Okay. Then they will be stable after a certain time, right? They will oscillate a bit and they will be stable after a certain time. Okay. And when they become stable, what I'm going to do is, if the weight P here is P, the tension here is also P, right? Then the same tension will continue until this point P. Okay? If this is Q, tension here is Q, and the same tension may continue until this point. Same tension may continue until this point Q. Clear? Okay? And if this weight is R, this will be equal to R, and the same tension will continue until this point as R. Okay. So what I'm going to do is, okay, what I'm going to do is, this is the idea. This is the whole idea of the practical. What we are going to do here is, we will mark the directions. Directions in the sense, here, resultant of P and Q has become R, right? Why? You have P in this direction, Q in this direction, and P and Q is balancing R. Clear? P and Q, force P and force Q is balancing force R, right? That means the resultant of P and Q should be equal to R. Clear? Resultant of P and Q should be equal to R. Clear? Resultant of P and Q should be equal to R. So what we do here is, we take a set square or sometimes a mirror. We take a set square or sometimes a mirror. I will place the set square like this. I will place the set square like this. Hope you can understand this diagram. Okay. Okay. That means if you have the string like this, do we have a set square? Anyone? No? No? Really? Okay. If this is the string, I will place the set square like this. I will place the set square like this. Okay. If this is the string, I will place the set square like this, and I will mark this point on the piece of paper. There's a piece of paper underneath, right? There's a piece of paper underneath. And there's a string like this. There's a string like this. Okay. I will get the set square and I will place it like this. I will get the set square and I will place it like this. I will place the set square like this. Clear? Okay. And I'll mark the bottom of it on the piece of paper. Clear? That means what I'm doing is, I'm ideally placing a dot very carefully below this string, right? I'm actually locating the position of this string on the piece of paper underneath, okay? I'm actually locating the position of the string on the piece of paper underneath, okay? Then again, I'll place the next string 2, okay? I will take this string, I will use the set square and put a mark here, two dots to mark this string. Clear? Two dots to mark this string. And to mark this string also, I will use 2 dots. Clear? And again to mark this string also, I will use 2 dots. Clear? Okay. 2 dots here, 2 dots here, and 2 dots here. Okay. Clear? To represent this string, I will mark 2 dots. To represent this string, I will mark 2 dots. To represent this string, I will mark 2 dots. Okay. Then I will take this piece of paper out. When I take that piece of paper out, when I take that piece of paper out, I will see altogether 6 dots, right? I will see 6 dots altogether, right? Here, 2 dots. Here, 2 dots. Here, again, 2 dots, right? Clear? So what I would do is, these 2 dots show the direction of this string, right? That means this string is in it's going in like this, right? Clear? These 2 dots show the direction of this string, right? And these 2 dots show the direction of this string. Clear? Okay. These 2 dots show the direction of this string. Okay. Clear? Now what I'm going to do is, I will use a certain scale. I will use a certain scale. That means, assume that this is 10 newtons. Assume that this is 8 newtons. Okay. Let's think about this later. Okay. I will use a scale. What is the meaning of a scale? I will tell, okay, I'll represent 2 newtons by 1 centimeter. I'll use a scale like this. I will represent 2 newtons by 1 centimeter. Clear? That means 10 newtons means 5 centimeters, and 8 newtons means 8 newtons means 4 centimeters, right? 8 newtons means 4 centimeters, right? Clear? So now what I'm going to do is, this is 10 newtons. Force P is 10 newtons, right? And 10 newtons means 5 centimeters. I will mark 5 centimeters from here. I will mark 5 centimeters from here. Clear? Then this force is Q, right? That means 4 centimeters. I will mark 4 centimeters. I will mark 4 centimeters here. Clear? Why? A proper parallelogram of forces should represent the force in magnitude and direction both. We use these 2 dots to figure out the direction, and we use the scale to represent the magnitude. Clear? To represent the magnitude. Clear? Now what we are going to do is, okay, now what we are going to do is, on this piece of paper, we will complete the parallelogram. On this piece of paper, we'll complete the parallelogram. How? I'll draw a parallel line for this one. I'll draw a parallel line to this one, and I'll draw a parallel line to this one, this will give me the completed parallelogram, right? This will give me the completed parallelogram. Clear? Then this diagonal will give me what? This diagonal will give me the resultant, right? This diagonal will give me the resultant. Clear? Assume that after measuring, now I take a ruler and measure this length. I take a ruler and I measure this length. Clear? Assume that I get 7 centimeters after measuring. Assume that I get 7 centimeters after measuring. Clear? That means resultant is 7 centimeters. That means the resultant is 7 centimeters. Clear? And 7 centimeters means, according to my scale, 14 newtons, right? According to my scale, 7 centimeters means 14 newtons. Now what I'm going to check is, I'm going to check two things to prove the parallelogram law. I'm going to use two things to prove the parallelogram law. What is that? One is, I have to check whether R is equal to 14. Why? Resultant of P and Q is given by the parallelogram. And from this setup, I know that resultant of P and Q is R, right? Okay. So if the law of parallelogram law is correct, okay, then resultant should be actually 14 newtons. Since I can measure that, I'm going to check whether it is correct. Okay. And this is the resultant of these two forces. Okay. This is the resultant of these two forces. And those two forces are balanced by this force. That means resultant of these two forces is this. Clear? And we use that resultant to balance R. And I have the line representing R2. And R and this resultant should be linear, right? Why, can you remember? To confirm that a system is under equilibrium under two forces, they should be linear, right? That you know, right? That you know from all levels, right? Okay. That you know from all levels, right? For a system to be, anyways, we are going to teach them separately, okay? We are going to teach point by point. The reason I'm doing this first is because some schools will get this as the only practical, okay? So in your term tests, definitely you will see this as a practical, okay? Because there's nothing else to give in your first term test. So for a system to be under equilibrium under two forces should be linear to each other. Two forces should be linear to each other, and the magnitudes should be equal and directions should be opposite, right? Clear? Directions should be opposite. Clear? So two things must confirm, two things should happen to confirm that parallelogram law is correct. What are they? The diagonal I get gives me the exact force equal to the force here. Clear? And the other one is the diagonal and this R force are linear. Clear? Usually you will never get this kind of a perfect result from this practical, okay? Never. Usually you will never get a perfect result like this. There are multiple reasons for that, okay? There are multiple reasons for that. I'll explain them later in the practical, but usually you will never get a perfect result like this, okay? But this is the practical. Now we have to discuss practical points. Practical points in the sense, anyways, for now you can read the practical note given in the tube. But when it is bit closer to A levels, we create a new practical tute for all the 40 something practicals, and we'll give that to you. Okay. For now, you can use the practical notes available in your tutes to go through the practicals. Okay. Okay. Then later, when it is close to A levels, we'll give a separate practical tute and a separate practical question book. Okay. Separate practical tute and a separate practical question book. Clear? Is it clear up to this point? Everything? Nice. Next, the next thing is the practical points behind this. Okay. Let's go to the practical points. What are the practical points here? What are the practical points here? First of all, we should talk about the imperfections. Another thing, I'll start with this. To draw these lines, we ideally use a set square, but there are some other options too, like using a mirror. If you have the string like this, you can place a small mirror underneath. Okay. If you have the string like this, you can place a small mirror underneath. Clear? Okay. On the paper. So when you look from above, you will see the string like this, and under that, through the mirror, you will see the image of the string like this. Okay. But when you like, now it shows two lines, right? It shows two lines. You know that you are exactly looking straight at the string when you can see only one, right? If you are looking from a side, you will see the string and the mirror image both, right? You have the string like this and the mirror like this. When you are looking from a side, you will see the string and the mirror image both, right? But you can confirm that you are looking exactly from above. Okay, you can confirm that you are looking exactly from above when you look like this. Okay, when you look like this, that means when your string covers the image of the string. Clear? Then you know that you are looking exactly from above. Clear? When the string covers the image of the string. Clear? You place your eye like that, and you take a pencil and you place the marks at the end of the mirror. That means you will see the image like this. At a certain point, you will see the string like this, and you won't see the image. You won't see the image. That means you are looking exactly from above. Then you take a small pencil and place two dots here and here. Place two dots here and here. This will also give you a perfect positioning of the string. Okay. Why don't we place the set square like this? If this is the string, why don't we place it like this, parallel? Why don't we place it? Why don't we place the set square parallel like this? Why don't we place the set square parallel like this? Because it will push the string. It will push the string, which will give a false reading. Clear? If you place the string like this, okay, it will, if you place the set square like this, it will push the string. You won't get the exact position. But when you place it like this, you get the exact position from this point, right? Clear? That is the target. Okay. So now everything about that is clear, but I said that you will never get a perfect result through this. Okay. Why? For this to happen, many scenarios should be confirmed. One scenario is for this P and this P to be equal. That means the tension here and tension here to be equal, there must be no friction here on the pulley. You can't have friction on the pulley, right? If you have a friction on the pulley, it will change the tension in this side and this side. Clear? And again, if you have friction here also, the same would happen. Okay? This friction issue we can check. How? Ideally, when you place things like that, there's only one perfect equilibrium location. There's only one perfect equilibrium location. Clear? What we do is we place a small dot below this junction. There's a junction where all three strings meet, right? We place a small dot below these three junctions, and I'll push this point a bit down. I'll push this point a bit down. If there is no friction, it will reach to the initial point again. I will take this point and I will drag it a bit down. Clear? When I release it, it will return to the same position again if there is no friction. If there is friction, it will not return to the same point. Clear? If there is friction, it will not return to the same point again. Clear? You pull this down, then when you release it, it will reach to the same point if there is no friction, otherwise it will not reach there. If you figure out that there is friction, what can you do? You can put some oil here and try to get rid of that, okay? You can put some oil here and try to get rid of that friction, or you can try to minimize that friction. Clear? You can try to minimize that friction by putting some oil here. Clear? That is the idea. So the next thing is, okay, the next thing is there are many other factors, okay? There are many other factors that decide whether the practical would give correct results or not. Definitely, the strings should be weightless, right? Strings should be weightless, right? Why? If there's a weight on the string, it should be added to the tension. That we are not going to do, right, in the practical. If there's a weight for the string, that should be added to the tension, right? Since we are not measuring that, weight of the string will bring a error into the practical. Clear? Weight of the string will bring an error into the practical. Okay, Mali, can you provide the weekly revision and all in the WhatsApp group and the Zoom chat? And like, we have physical copies, right? Distributed here. Inform Visha. Okay, clear? Got the idea until this point? Yeah. So what we are going to do is the tension, like will change if there's a weight on the string, but some stuff we can't get rid of, right? You can't find weightless strings in real life, right? You can't find weightless strings in real life, so some issues we can't solve. That's why I said that no matter how careful you are, you will never get a perfect result, okay? When you are doing this at the lab, you will never get a perfect result, no matter how careful you are, okay? Then, one main issue that could happen is, these pulleys, they may not in the same plane. Same plane means this parallelogram scenario works if everything is in the same plane. That means for a 2D system, that means if the force, until now we discussed everything in the 2D domain, right? That means if there is a force like this, F1, and if there is another force like this, F2, you get the resultant from the parallelogram law, and all F1, F2 and R are in the same plane. Clear? All F1, F2 and R are in the same plane. Clear? They are in the same plane. All F1, F2 and R are in the same plane. Clear? Otherwise, okay, Like, these theorems don't show you forces or don't give you results for forces that are in different planes. That means if F1 is in this plane, if F2 is going like this away from the board, then these are not coplanar forces. That we didn't discuss until now. All the vector theorems we learned in the vectors lesson are for coplanar vectors. That means vectors that are in the same plane. Okay? Vectors that are in the same plane. Okay? Clear? All the theorems we discussed in vectors lesson are for vectors that are in the same plane. Same plane means, for an example, this board is a plane. This board is a plane. And to draw a vector parallelogram, all three forces should be in that plane. If one force is like this on the plane, and if the other force is coming out from the plane, and if R is on the plane, you can't create a relationship using this. Your vector theorems don't work there. Okay? We only know how to work with 2D systems. Okay? In our syllabus, we know how to work with 2D systems only. Okay? Clear? So sometimes these two pulleys, they may not be in the same plane. Ideally, these two pulleys should be in the same plane, parallel to each other. They need not to be like this. They can be like this. One pulley can stay here, another pulley can stay here, no big issue. But still they should be in the same plane. They should be in the same plane. You can't have one pulley in one plane and the other pulley in another plane. Okay? Then these theorems would not work. But ideally in the lab, sometimes these two pulleys may be in two different planes. Okay? Then this theorem will be definitely wrong. Okay? Clear? Then you will not get the correct result. Then what are the other factors? Other factors are sometimes you have these three trays. Sometimes you have these three trays and you sometimes don't add the weight of the tray to this weight, right? Sometimes we don't add the weight of the tray to this weight. Again, another reason to get wrong results. What else? Sometimes you use twisted strings. Twisted strings. That means you can find different strings. There are strings that are not twisted. I think nylon or something like that. They are not twisted, right? Yeah. That twisted strings means some strings you can find as a single strand. Only a single strand. Some strings are made by using multiple strings, right? Clear? Multiple strands. You should not use strings like this. Why? These kind of strings tend to rotate. Why? Their tension may change, right? These kind of strings, they tend to rotate, right? Why? There are multiple strands, so they will turn against each other, then again return to the initial state, like that. Okay? Okay? So these kind of strings tend to rotate. Okay? Then you can't get the proper result. Why? When the string rotates, its tension may change here and there. Clear? Okay? Another reason to get wrong results. Okay? And definitely you may get wrong results if you definitely you may get wrong results if you don't mark the perpendicular projections properly. Okay? These two dots, if you don't mark these dots carefully, definitely you will get wrong results. Clear? These are the again, sometimes some people do this mistake. The plate is like this. The plate is like this. Okay? The board is like this. Sometimes you place your plates in a way that plates are here. Instead of placing the plates like this, you place the plates like this. Then what is the issue? When you place the plate like this, it tends to it tend to collide with the board time to time. Clear? It will rub with the board. It will collide with the board behind that. Then what happens? If it touch the board, there's a friction there, additional force into the system. Clear? Ideally, we expect you to place it like this, where it does not touch anything else. Clear? If you place the plate like this, if you place the plate like this, it will touch the plate. Clear? It will touch the board behind this. Clear? It will touch the board behind this. Then these forces will bring additional forces, okay, into the system. Okay? Clear? And we don't measure that force. That is the issue. Okay? We don't measure that force. Clear? Ah. So this is the idea of this practical. Clear? What we do is, ideally in this practical, what we usually do is uh, we do this practical. Okay, we do this practical. We first prove the vector parallelogram law. We first prove the vector parallelogram law. So to prove the vector parallelogram law, we use this whole setup. Okay, to prove the vector parallelogram law, we use this whole setup. Okay, then after that, okay, then after that, what we usually do is, after proving the parallelogram law, here we know this weight, and this weight, all three, when we are proving the parallelogram law. Now what we usually do is, now if we somehow prove the parallelogram law, now we know that the parallelogram law is correct and the system is accurate. Then we use this to measure unknown mass. How? You remove R and you put an unknown mass here. You put an unknown mass here. You do the same practical again. You get the length of the diagonal, and that is the unknown weight, right? Clear? You do the same practical again, and you measure the diagonal. You get the unknown weight. Usually, even though they ask in the paper, even when they ask you to find a unknown weight in the practical, ideally you should, before finding the unknown weight, you should prove the parallelogram law. Okay? Before finding the unknown weight, you should somehow find three known weights, put them here, here, and here, and you should first try to prove the parallelogram law. Clear? You should somehow try to prove the parallelogram law. Clear? Clear? That is the idea. Okay. So like go through your tute a bit, read the tute a bit. Everything is included in your tute, but try to read the tute a bit. Now only we can move to new parts. Now only we can move to new parts. Malik, put the tute in the Zoom chat and the WhatsApp group, both. Okay. So like practicals, when it comes to practicals, what you should do is ideally prepare a proper note for practicals. Okay. That means now you have a like maybe 90% complete practical. Now you have in your like in the tute given, right? In the tute given, you can find you should put the practical in the WhatsApp group. Put the tute in the WhatsApp group. Okay. Uh, like ideally, like you have maybe 80%, 90% complete practical tute in the tute. Okay. What I need you to do is when in the school, if they teach you the practical, if there are some extra points, write it down maybe in this tute, or prepare your own practical tute, or take a print out of the practical guidebook available online. Okay, there's an official practical guidebook. Take that. Take the important factors from my tute and put them on that guidebook. And from important points you learned in the school also in the same point, same place. Things you learned when you were doing the practical at the lab in the same place. Like that, you should have a one place where you have written all the practical related points. Okay. Yes, when it is close to A levels, we do that for you and we give you a practical tute. But until then, you need your own practical tute. You should maintain that. Okay. So you either write everything on my tute or take everything from my tute and everywhere else and put them on the practical guidebook printout you have, or you prepare your own short note. You write everything and prepare your own short note. Okay. Choose whatever the thing you like. Okay. At the end of the day, ideally what should happen is you should go through the whole, like you should have a 1 point. Okay. You should have 1 point. Okay. You should have 1 point with all the practical points. Clear? You should have one place, one book or one tute or somewhere like that with all the practical points together. Okay. Because otherwise you will not remember anything after 6 months. You won't remember anything, right? You won't remember the things that you faced when you were doing the practical at the lab. You won't remember the things taught at the school. You won't remember everything you learned here. Okay. It's only one practical for now. Yes, you will remember. But after that, we keep on doing, and there are 40 something practicals. Okay. Okay. And there's a one full structured paper you are getting from that. Okay. 4 structured questions in every A level paper. You get 4 structured questions only from practicals. Okay. Only from practicals. You have to be really comfortable with the practicals. Clear? Okay. So now only we are actually moving to coplanar forces. Okay. I'll give that. Okay. Now only we actually move to coplanar forces lesson. Okay. This is also related to the coplanar forces lesson. This is the proof of parallelogram laws. Some teachers teach this in Newton's laws. Some teachers teach this in vectors. Some teach this in coplanar forces lesson. Okay. Now we are going to discuss about a domain that we didn't discuss yet. Okay. We don't need a separate lesson to learn about linear forces. Why? We learned everything about linear forces in the lesson uh, vectors and Newton's laws, right? How to get the resultant of linear forces, how to get the sum of linear forces, how to subtract linear forces, vector triangle, vector parallelogram, vector polygon, everything about linear forces we learned, right? We learned everything about linear forces. But we didn't learn about rotations and tendency to rotation. Rotations and tendency to rotation. With that we have to start this. Okay. We first discuss that, then we move to equilibrium. Okay. So the first main topic that we learn in coplanar forces is something you already know from O levels, moment of force. Can you remember from O levels? A moment of force? Moment of force? Moment of force. What is moment of force? That means moment of force means tendency to rotate something. You take this. You can't rotate this by a linear force. So see, I'm applying a force from my hand. I can't rotate it, right? I'm applying a force from my hand, but I can't rotate it. How can I rotate this? I need a moment. See? I need a moment. Clear? This is moment of forces. What that means, tendency to rotate something is the moment of force, okay? Or ability of a force to rotate something, clear? Ability of a force to rotate something is the moment of force, clear? Then there are two main factors that decide the magnitude of a moment, that you know, right? There are two main factors that decide the magnitude of a moment. What is that? One is magnitude of the force, another one is perpendicular distance to the force, right? That means, see, I'm applying a force, it rotates, see, it rotates. I'm applying the same force, but it's really difficult for me to rotate it, see? Okay, it's really difficult for me to rotate it. Even in a door, if this is the door, and if it is connected like this by two hinges, okay, we open the door from a handle here, right? We never place the handle here. Why? It is really difficult to open the door if the handle is here, right? So when it comes to a moment, okay, when we discuss about moments, okay, magnitudes of moments, okay, magnitudes of moments are decided by magnitude of the force and the perpendicular distance to that force. That means F into X, clear? Magnitude of the force into the perpendicular distance to that force, clear? Clear? Fx, okay? Fx, clear? And this is definitely a vector. Moment is a vector. And what is the dimension of moment? What is the dimension of moment? What is the unit? Moment is force into perpendicular distance. Moment is force into perpendicular distance. Force means newtons. Displacement means meters, right? So moment is Newton meters. Moment is Newton meters. Clear? What is the dimension? Force means M L T minus 2. Force means M L T minus 2. Then distance means L. Distance means L. M L T minus 2 into L. Clear? Which gives you M L squared T minus 2. Clear? Then what is the direction? What is the direction of a moment? How do we get the direction of a moment? How do we get the direction of a moment? Did you learn right hand law in all levels? Yes, some didn't, right? Or everyone? Yes. Okay. What is right hand law? That means the problem is when it comes to rotations, you can't use the terms clockwise rotations and anti-clockwise rotations. Why? It's not very convenient. It's not very convenient to use clockwise and anti-clockwise. Why? How are you going to draw vector triangles for this? If you don't have a proper direction, you can't draw vector triangles for clockwise and anti-clockwise and get the sum, right? Okay? You can't get resultants like that, right? You can't get resultants like that. Clear? You can't draw clockwise stuff and anti-clockwise stuff and get the resultant, right? Clear? You can't draw. So, like, we need to define a proper direction for vectors. Clear? Every vector should have a proper direction defined. Clear? So for this, we introduced a method to define the direction. that is right hand law, right? That means if it rotates like this, you take your right hand, you rotate other fingers in the direction of rotation. Clear? You take other fingers and turn it in the direction of rotation, and the thumb will give you the resultant. Clear? The thumb will give you the direction. Clear? So it rotates like this. If it rotates like this, take the right hand, move your other fingers in the direction of rotation, and the thumb will give the direction. Clear? Now, since you have a proper direction, you can even apply vector parallelogram laws, vector polygon laws, vector triangular laws for moments too. How? How? See? Pay attention. Assume you have a moment like this. You have a moment like this. Uh, like this. Towards the board. Towards the board. You have a moment like this towards the board. Okay? That means that moment it rotates the system like this. Clear? It rotates the system like this. That means you get the resultant in this direction. So this vector you can represent like this. Clear? Clear? Then you again have something like this. Like this and into the board. Like this. Okay? That means it rotates like this. It rotates like this. Clear? If it rotates like this, your direction is this. Your direction is this. Clear? It rotates like this. That means into the board. Okay? Not this. Okay? This is a force going into the board. I can't draw it properly. This is a force going into the board. Okay? I mean, if I explain it, there's a rotation like this, and there's a rotation like this. Clear? For this rotation, the direction is this. For this rotation, direction is this. Now you have two arrows. You can apply vector triangle. You can draw a vector triangle for this, right? See? You can draw a vector triangle for this and get the resultant, right? Clear? You can draw a vector triangle for this and get the resultant. See? Okay? Otherwise, how can you solve if it is a rotation like this and another rotation like this? You can't apply laws to add them, right? Because these are rotations. But using the right hand law, what we do is we define a proper direction to the rotation. Clear? Okay? In the rotational motion lesson also, this is how we define the direction. Because we need a proper linear direction for vectors to do vector arithmetic, vector calculations. Clear? Is that clear, everyone? Yes? So, like, if you have a point like this, if your force is 5 newtons, if the distance is 2 meters, what is the moment then? What is the moment? Force into perpendicular distance, right? Force into perpendicular distance, which means 5 newtons into 2 meters, which is 10 Newton meters. Clear? So if the point I'm considering, if a force goes through that point, what is the moment then? 0, right? Why? Force is 5 newtons. Force is 5 newtons. The distance from the considered point is 0, right? Clear? You get a moment of 0. Clear? You get a moment of 0. Got the idea? So quickly go to exercise 3. Quickly go to exercise 3. You can find the tutor in the Zoom chat and WhatsApp groups. If you can't find the tute, let me know. Exercise 3. Do maybe question 1, 2, and 5. Question 1, 2, 5 of part 1. Then question 2. Question 1, 1, 2, 5, and question 2. If you need, I mean, if you are like planning to go to a government university and like if you don't need this kind of political nonsense, you have to go to University of Moratuwa or Colombo Medicine. We actually haven't seen anything related to politics at University of Moratuwa. I have never. No ragging, no politics, nothing. I mean, I don't know whether there are politics, but we haven't seen anything. No influence because people have more than enough work to do. Same story, Colombo medicine. The people don't have proper enough time to eat, so they don't have time to do politics. Tubes will be delivered. Okay, tubes will be delivered. Send a message to this number. Don't physical students don't send messages to this number. You can get the tube next week at the class. Online students, send the message to this number 070-154-6825. We'll deliver you the tubes. Okay, 070-154-6825. We'll deliver you the tubes. Physical students, don't request tubes through this. You can get the tube next week from the class. Or else within the week also, if you are coming to the institute, you can collect the tube from the institute. Same story for online students too. Okay. If my staff is here and if you like pass the institute, just come to the institute and get the tute. Yeah, there's a question about talks. I'm going to discuss about that too. Okay. Okay. Uh, so like the exercise is simple actually. Exercise is simple. Uh, so there's an object like this. We don't have to think about the object. Exercise 3, question 1. Exercise 3, question 1, part 1. Point O is this. You have 20 newtons like this, and the perpendicular distance is 2 meters. Then the moment is force into perpendicular distance. Force is 20 newtons and distance is 2 meters. So 20 into 2 means 40 Newton meters. Clear? You get 20 into 2, that means 40 Newton meters. Clear? 40 Newton meters. Then question 2. Question 2. Again, this is the point. This is 3 meters. And you have 10 newtons here. You have 10 newtons here. Then what is the moment? Moment is force into perpendicular distance. Force is 10 newtons. Distance is 3 meters. So you get 30 Newton meters. Then what about question 5? Question 5. This is point O. This is point O. This is 5 meters. This is 5 meters. And this is 10 newtons. This is 10 newtons. 10 newtons. What is the moment here? For this, what we should do is, this is 10 newtons. This is the force, okay? This is the force. Moment means force into perpendicular distance, right? Moment means force into perpendicular distance, right? Perpendicular distance for this force is, if this is the path of the force, this is the perpendicular distance to the force, right? If this is the path of the force, this is the perpendicular distance to the force, right? This is the perpendicular distance to the force. And this angle is 30 degrees. This angle is 30 degrees. Clear? Then what you get here is force is 10 newtons. Force is 10 newtons. Clear? Force is 10 newtons. And this perpendicular length is, what is the perpendicular length? It is 5 sine 30, right? If this is 5, if this is 30, this is 5 sine 30, right? This will become 5 sine 30. Clear? 5 sine 30. Clear? That means 5 into half. 5 into half, which means 2.5. Which means 2.5. Clear? It is 2.5. So 10 into distance is 2.5. Okay? Which will be equal to 25 Newton meters. Clear? 25 Newton meters. Okay? Let's go to question 2. Let's go to question 2. And regarding today's interval, like can we go with a small edit, because today there's a small meeting for me at it's 5:51 at 6:45. Can we continue until 6:45? No? I'll give you a 5-minute interval in between. Okay, is that okay? Yes? Yeah, manageable. It's manageable because we don't have the people who are shouting today. So you can't make noise. So due to that reason, it will be successful, right? Okay. Otherwise, you are the kind of people who ask for 5 intervals, right? This class requested for 5 intervals in one class, right? Yeah, this was the class. Yeah. So what I would do is a small change of plans for today about the interval. Usually what we do is, and for new students also, usually what we do is from 2 to like not about the today's plan, I'm telling the rough plan for everyone. From usually from 3 to 4 you have a paper, from 4 to 7:30 you have theory, from 7:30 to 8:30 you have the paper discussion. That is the plan we follow every week, and in between you have a interval. So today I mean I will give you maybe a 5-minute interval. Okay, I'll give you 5-minute interval, and I will give you a proper interval at 6:45. Okay, I will give you a proper interval at 6:45. Only for today. Okay, a small change of plan for today. Okay, so only for today I will give you a 5-minute interval in between. Don't go at that time. Okay, it's just 5 minutes. It's just 5 minutes. If you need to go to washroom or anything like that, yes. Then after that I'll give you a proper interval at 6:45. Okay, let's follow that plan only for today. Okay, it's only for today. Okay, so like question two. Uh, then I can cover a lot of theory points. Then I can let you do some questions after the interval and wind up the session for today before the paper class. Okay, and as usual at 7:30 we'll start the paper discussion too. Okay, so again it's a bicycle pedal. You don't have to think about the shape. You don't have to worry about the shape actually. You have the pedal here. You have the pedal here. You are applying a force of 200 newtons here. You are applying a force of 200 newtons here. And the perpendicular distance is 20 centimeters. Perpendicular distance is 20 centimeters. Clear? So the moment is force into perpendicular distance. Force is 200 newtons. Force is 200 newtons. Perpendicular distance is 20 centimeters. 20 centimeters. Then in the next scenario, you have this. You have this. This is the pedal. You apply 200 newtons like this. You apply 200 newtons like this. Clear? And this length is 20 centimeters. This length is 20 centimeters. This angle is 60 degrees. This angle is 60 degrees. Now it is moment is force into perpendicular distance. So if this is the force, if this is the path of the force, this is the perpendicular distance to the force, right? This is the perpendicular distance to the force, right? This is the path of the force, and this is the perpendicular distance to the force. You have to multiply by that. Okay. So the force is 200. Force is 200. Perpendicular distance is 20 cos 60, right? This length is 20. This angle is 60. Then this becomes 20 cos 60, right? This length becomes 20 cos 60. Clear? So the perpendicular length is 20 cos 60. Clear? perpendicular length is 20 cos 60. Okay, so you will get 200 into 20 into cos 60 means half. Clear? That's how you get the moment. Okay. This is how you get the moment. Clear? Sorry? It's centimeters, right? Yeah. It was centimeters, so you need 10 to the power minus 2 also. It is centimeters. You have to convert centimeters into meters, so you should put 10 to the power minus 2. Yep. Thank you. Okay. So this part is simple. Then again, you have the concept called resultant moment. Okay. You have the concept called resultant moment. What is the meaning of the concept called resultant moment? Concept of resultant moment is if you have F1, X1, F2, X2, F3, X3, F4, X4, multiple forces like this, okay? If you have multiple forces like this, okay? Around this point, if you need to get the resultant, you just get the sum. So when you are doing calculations like this, you ideally should show the direction of the moment. When you are showing direction of the moment for the sake of calculations, it's okay to show like this, okay? For the sake of calculations, when you are showing the direction of the moment, it's okay to mark like this, okay? You are just representing, okay, I'm showing the moment in this direction, that's all, okay? So if you are doing this for the sake, when you are doing this for the sake of calculation, it's okay, okay? It's okay when you are doing this for the sake of calculations. But if they specifically ask you, okay, now show me the direction of the moment, then you should apply right hand law and show the proper direction, okay? That's how it should happen, okay? So even for these kind of calculations, now there are some moments in this direction, some moments in opposite direction, right? So when you get the resultant moment, when you calculate the resultant moment, you should choose the positive direction. So I will choose this as the positive direction, okay? You should choose the positive direction, clear? So I'll choose this as the positive direction, positive moment, okay? Then I will write F1, F1, this distance is x1 and it is in this direction. F2, F2, x2 and it is also in this direction, right? And the next one, F3, x3, but F3, x3 is in opposite direction, right? F3, x3 is in opposite direction, clear? So it should be written as minus F3, x3, clear? It should be written as minus F3, x3, clear? Then what about F4, x4? It's also in opposite direction, right? F4, x4, this is my positive rotation direction. F3, x3 opposite. F4, x4 opposite, ne? So I should write minus F4, x4. Got the idea? Minus F4, x4. Clear? Got the idea? So that, like that you can find the resultant moments of systems, okay? Go to exercise 4. Go to exercise 4. Try question 2, 4, 5 and 6. Okay, so while doing this question, like you can take a 5-minute interval, okay? Okay, you can take a 5-minute interval. I'll start this discussion around maybe 6 past 6. If you need to get some water or food or need to go to the washroom, it's okay to leave and come back, okay? Just a 5-minute interval. I will give you the proper interval only for today at 6:45. Okay. There's a lot of messages. Talk and moment I'll explain. Ideally, moment is cross product. It's true, but don't use that in papers. Okay. Don't use that definition in papers. Okay. Ideally, moment is moment and circular motion and rotational motion. Everything comes to cross product. That's why you are getting a perpendicular direction. Maths people would know this, but don't use those concepts in physics papers. Okay. You won't get marks. Okay. You won't get marks. So don't use the concepts of cross product, properties of cross product, calculations using cross products in rotational motion or moments. Just use this method because it's not safe actually to use concepts of cross product in the paper. So as per our syllabus, you just consider it as the force and the perpendicular distance, okay? Not the cross product between them. Okay, I'll do a few questions. Exercise 4, question 2. Exercise 4, question 2. This is point O. This is point O. You have 10 newtons here, 10 newtons here, 8 newtons here, 8 newtons here, another 5 newtons here, another 5 newtons here, 10 newtons here, 8 newtons here, another 5 newtons here. This length is 2 meters. This is 1 and this is 1. Okay. So quite easy. You first choose a proper positive direction. I'll choose this as the positive direction. I'll choose this as the positive direction. So I get 10 into the perpendicular distance is 2. Then, because the direction of rotation is this, and I get 5. I get 5. And the distance is 2 plus 1 plus 1, altogether 4. Distance is 4. Distance is 4. Distance is 4. 5 into 4. 5 into 4. Clear? But this one is opposite, right? 8 newtons is opposite. So minus 8. Minus 8. The distance is 2 plus 1, 2 plus 1, which is 3. Distance is 3. 2 plus 1 is 3. So you can get the resultant moment like this, right? You can get the resultant moment like this. Okay. Next, question 4. Question 4. Question 4. You have a system like this. 20 newtons here. Another force here. I actually don't care about that force. They haven't even give the magnitude of that run, right? 20 and another force. And this is 2 meters. You have 4 newtons down. 4 newtons down. Another 8 newtons. Another 8 newtons. This 30 degrees. 30 degrees. And another 6 newtons. Another 6 newtons. So here also choose a positive direction. First choose a positive direction. First choose a positive direction. Now it's not force into distance, force into perpendicular distance, right? So when you consider this force, perpendicular distance is this, right? When you take this 4 newtons and this point, perpendicular distance is this, right? Which is 2 cos 30, clear? This distance is 2, it's 2 cos 30, right? It is 2. So I multiply force into perpendicular distance. What is the force? 4 newtons. Force 4 newtons. Perpendicular distance is 2 cos 30, right? Perpendicular distance is 2 cos 30. 2 cos 30. Perpendicular distance is 2 cos 30. 4 into 2 cos 30 plus 8 into 8 into this force is 8. This is 2 meters and this is 2 meters. Altogether 4 meters. So the perpendicular distance is this, right? Perpendicular distance to this 8 newtons is this, right? Which is 2 plus 2, 4 cos 30. 4 cos 30. 4 cos 30. Clear? Force is 8. This length is 4 cos 30. Through the angle you get cos. But this is in opposite direction, right? See, it rotates the system in opposite direction. These two tries to rotate the system in this direction. This tries to rotate the system in opposite direction. So it gives you minus force is 6 newtons, force is 6 newtons, and the perpendicular distance is, what is the perpendicular distance? Perpendicular distance is this. This is the force, and this is the perpendicular distance, right? This is the perpendicular distance, right? This is the force, this is the perpendicular distance, which is 4 sine 30, right? Which is 4 sine 30, right? Clear? This length is 4, this is 30, so you get 4 sine 30, clear? You get 4 sine 30. 4 sine 30. 4 sine 30, clear? Clear? Ah. This is how you get the resultant in this case. Clear? 2 cos 30, 4 cos 30. This is 4 sine 30. Clear? Let's try question 6. Question? Go to question 6. It's not 4 cos 30, it's 4 sine 30, okay? Why? See, try to understand the concept. This is the point you are considering. This is the point you are considering. There's 4 newtons going like this. There's 4 newtons going like this. Another 8 newtons going like this. Okay? Another 6 newtons going like this. Clear? So what is the perpendicular distance here? This one, right? What is the perpendicular distance here? This one, right? What is the perpendicular distance here? This one. Clear? So here you have 2, here you have 2, and here you have 30. So what is this? 2 cos 30. Here you have 4, 2 plus 2, 4, and 30. Then what is this distance? 4 cos 30. 8 into, this length is 4, 4 cos 30. Clear? 8 into 4 cos 30. Here, this is the perpendicular distance, right? Clear? Which means 4 sine 30. Clear? It is 4 sine 30. See? This length is 4 and you get the sine 30 component, right? Clear? When you go away from an angle, it is sine. When you go over an angle, it is cos, right? So this component, this length, this perpendicular distance is 4 sine 30. Clear? It is 4 sine 30. Good question. Why didn't I even think about 20 Newton? This is my point. There are two forces going like this. Yes. One is 20 Newtons. This is my point. And there are two forces going like this. But I don't even care about these two forces, right? Why? Distance is zero. These two forces goes through my point. This is my point I'm considering, right? I'm considering the moment around O. And these two forces go through O, right? This is point O. And this 20 newtons and this force goes through point O, right? These two forces go through the point O, so I don't have to think about them, right? I don't have to worry about them, clear? Because they directly goes through the considered point, which won't create a moment, but because for the moment, you need a force and displacement both, clear? You need a force and displacement both. Let's go to question. Now, is that clear? The student who asked about 20 newtons, is that clear? What happens to 20 newtons? Is that clear? Yeah, and about tomorrow's sessions, just let me in the Zoom chat or uh, like message to my WhatsApp number whether like you need to some like me to do something tomorrow. Then based on the count, I'll consider whether I'm doing a similar session tomorrow, maybe to go through some rotational motion points or something like that. I'll try to discuss some rotational motion questions or something like that. I can try if required, online or physical. But if nothing happens, if there's no such request or if there's no enough count for a session like that, what I would do is anyways, I will discuss a term test paper tomorrow evening, okay? As usual, I will discuss a term test paper tomorrow evening as usual, okay? That is the plan. If there's enough request, if you can confirm the count, if there's a set of students who will be coming for a separate session, maybe I can discuss like last week we did a rotational motion for 6 hours and finish that, okay? Targeting the term test papers, like term test of the private school students. If you need, you can watch that recording too. Last week, Friday, I did 6 hours continuous and finished rotational motion. Don't worry, we'll do that in the main class just for the sake of term test for the of some students who are having term test on 24th and 25th. But like if you have a similar request, let me know. I'll try to do something tomorrow. I'll inform in the group. Otherwise, as usual, I'll discuss a term test paper tomorrow evening. Okay, that will be online then. And next Monday and Tuesday also you will have similar sessions. I'll let you know. Won't be from 8 to 2 maybe from 8 to 12, smaller sessions to discuss some term test papers, to discuss we last week, Tuesday and Wednesday we finished work power energy. We'll do some similar sessions next Monday and Tuesday to do some additional questions from work power energy to get more comfortable with work power energy, to discuss some past paper questions from work power energy. Okay. And if possible, to do some term test papers. For things like that, I'll do sessions next week also, Monday and Tuesday. Monday morning and Tuesday morning as usual. Monday morning for full English medium students. Tuesday morning for Sinhala and English medium students. So next week also the sessions would happen. Question 6. Question 6. You have a system like this. You have a system like this and like this. Looks like a wheel. Yeah, this is the point you are considering. Or there's 40 newtons here. 40 newtons here on the small wheel. 40 newtons here. 40 newtons here. And you have 50 newtons here. 50 newtons here. This will be 10 centimeters. This is 10 centimeters. This is 20 centimeters. This is 20 centimeters. It is 10 centimeters and 20 centimeters. So you choose a direction for the moment. I'll choose this direction. I'll choose this direction. So 50 newtons, try to rotate this wheel in that direction, right? So it is 50. It is 50 into the perpendicular distance. What is the perpendicular distance? It is 20 centimeters. Perpendicular distance is 20 centimeters, right? 50 into this perpendicular distance, it is 20 centimeters. Clear? This distance is 20 centimeters. 20 into 10 to the power minus 2. Then you have 40 newtons, but it's trying to rotate the system in the opposite direction, right? This is the position. It tries to rotate the system in the opposite direction, right? Okay, opposite direction. So it will be minus 40 into distance to that force is 10 centimeters. Distance to that force is 10 centimeters. Clear? This is 40 and distance to that force is 10 centimeters. 10 into 10 to the power minus 2. 10 centimeters. 10 into 10 to the power minus 2. 40 into 10 into 10 to the power minus 2. Clear? It's in the opposite direction. Clear? Clear? Any questions up to this point? Any questions up to this point? Okay, I'll move to like couple of forces next. Before couple of forces, I'll do principle of moment. Okay, skip one topic, go to principle of moment after exercise 5. Okay, what is principle of moment? What is principle of moment? Principle of moment is this. Okay, is everything is clear up to this point, right? Okay, so now you know how to get the resultant of forces, right? That means assume you have 5 newtons, 3 newtons and 2 newtons. What is the resultant of these three forces? 10 newtons, right? You have 5 newtons, 4 newtons and 1 newtons. What is the resultant? What is the resultant? 2 newtons, right? 5 plus 1, 6, minus 4, because it is opposite, right? This gives you 5 plus 1 minus 4, right? 5 plus 1 minus 4, right? Clear? Which gives you 2 newtons. Clear? This gives you 2 newtons. Okay? Now, can you remember force is a special kind of vector where knowing the magnitude and direction only is meaningless? Okay, why? You have 5 newtons in this direction. You apply it here on the object. Object will move straight forward. You apply it to this end. Object will try to rotate. See? Result of a force. Okay, usually when it comes to vectors, knowing the magnitude and direction is enough. When it comes to vectors, knowing the magnitude and direction is enough usually. But when it comes to this one, okay, when it comes to this one, only magnitude and direction is not enough. Clear? You need point of action too. Clear? That means, see, now I'm applying 5 newtons in this direction. Nothing happens. Okay? But if I come here and try to apply 5 newtons, I can push this display, right? I'm applying 5 newtons in this direction. See, nothing happens. I apply the same 5 newtons here. The board will be pushed, right? See? Same force, same direction, but based on where the force is acting, the result varies, right? Result varies. That means force is a special kind of vector, as we learned when we were learning vectors. It is a special kind of a vector where knowing the magnitude and direction is not enough. You have to know the point of action or the line of action too. So if someone asks you the resultant 5 plus 3 plus 2 is 10, telling that is not enough. You have to tell the point of action of the resultant. You have to tell the point of action of the resultant. Clear? There's a rule for this. Rule is sum of moments of a system is equal to the moment of the resultant. What is the meaning of that? It is like this. See, there's a stick. This is the point O. You have 5 newtons at a distance of 2 meters. Another 5 newtons, another 2 meters. And you have another 2 newtons. Okay. The distance is again 2 meters. Now what is the resultant of these forces? Downward 5 plus 5 plus 5 minus 2, right? 5 plus 5 minus 2, right? Which gives you a resultant force of 8 newtons. 5 plus 5, 10, minus 2 means 8. It gives a resultant of 8 newtons, right? It gives a resultant of 8 newtons. Clear? But you have to find the point of action of this 8 newtons. The theorem is resultant of force is the force that can do the same thing as the other forces. So the law is what is the overall moment by these people? Moment around O is 5 into moment is 5 into 2 plus 5 into 4. This distance is 4 plus 5 into 4 minus, this is a negative moment, right? Opposite direction, minus 2 into 6. Clear? The law says that the sum of these moments is equal to the moment of the resultant. That means if I think that this 8 Newton resultant force, if I think that it acts at a distance x from point O, okay, if this resultant force 8 acts at a distance of x from O, the moment that it would create is 8 into x, right? The moment that it will create is 8 into x, right? These are equal. Sum of moments of each force is equal to the moment of the resultant. Clear? Sum of moments of each force is equal to the moment of the resultant. Clear? So based on that, I can find what is x here? 10 plus 20 minus 12 divided by 8. Like that, I can find the position of the resultant. Clear? I can find the position of the resultant. Clear? Okay. So what I need you to do is finish all the questions of exercise 6. Finish all the questions of exercise 6. And if you are done with 6, try to finish questions of exercise 7. You will find this bit difficult because there's a small theory point behind this. Finish these two. You can take a maybe 15-minute interval, okay, and start doing these questions, okay. I'll be here within like around 20 minutes, okay. So what I need you to do is take a 15-minute interval and start doing these questions, okay, based on this concept. Okay. Hope you're done with the questions. So exercise 6, exercise 6, exercise 6. Question 1. Question 1. AB is 2-meter length. AB is a light horizontal length, a rod of length 2 meters. So you have a rod like this, and the length is 2 meters. Mass 1 kilogram, 2 kilogram, 3 and 1.5 and 2.5 are placed at points 5, 60, 90, 130 and 200. At a distance of 5, at a distance of 5, 60, 90, 90, 130, 130 and 200. 200. From the end A of the rod. From the end A of the rod. 1, 2, 3, 1.5, 2.5. 1, 2, 3, 1.5. 1, 2, 3, 1.5, 2.5. 2.5. Then magnitude of the resultant of weights acted upon by these masses and the distance from NA of the rod to the point of action are. So what is the resultant weight? 1 means 10 newtons, 2 means 20 newtons, 3 means 30 newtons, 1.5 means 15 newtons, 1.5 means 15 newtons, and 2.5 means 25 newtons. 25 newtons. So the idea is principle of moments. That means the sum of moment of each force, sum of moment of each force around point A is equal to the moment created by the resultant. So what is the resultant first? 10 newtons, 20 newtons, 30 newtons, 15 newtons, 25 newtons. So what is the resultant? 25, 35, 40, 40 plus 30, 70, 70 plus 20, 90, 90 plus 10, 100, right? So the resultant force is 100 newtons downward. Resultant force is 100 newtons downward. This is the resultant, 100 newtons downward. So around point A you have 10 newtons, 10 newtons at a distance of 5, 20 newtons at a distance of 60, 30 newtons, 30 newtons at a distance of 90, 90 plus 15 newtons, 15 newtons at a distance of 130, then 25 newtons, 25 newtons at a distance of 200, 200 equals resultant force is 100 if the resultant force 100 is acting at a distance of x. If the resultant force 100 is acting at a distance of x. Okay. If the resultant force 100 is acting at a distance of x, it becomes 100 into x, right? It becomes 100 into x, right? Resultant force is 100 and the distance is x. It becomes 100 into x, right? Clear? You can find x. That is the distance to the point of action of the overall weight, right? Okay. So what is the answer? What is the answer? 10 into 5 plus 20 into 60. 10 into 5 plus 20 into 60 plus 30 into 90 plus 15 into 130 plus 25 into 200 divided by 100. 109. 109. Clear? So the resultant acts at a distance of 109 centimeters, right? 109 centimeters. Clear? Uh, Something to add here, okay? Something to add here. This is, okay? This is, I actually wrote it in centimeter. I didn't convert it into meters, okay? I didn't convert it into meters because anyways, I can get the final answer in centimeters, right? That's why I didn't convert it into meters. And here, one thing to focus is, okay, one thing to focus here is, one thing that I consider here is like this is the exact concept that we can use to find the center of mass. Can you remember that term, center of mass or center of gravity? What is center of gravity? I'll explain a bit next week. I'll do that properly. What is center of gravity? Center of gravity is this object, different points of this object. It's made out of uh, millions of particles, right? Each particle have its own weight. Each particle have its own weight. Clear? But there's a point that you can balance this, right? In I think last week seminar I explained that, right? Did I? You can bring your hands together like this towards each other. See? Then you can figure out a point that you can balance this. See? See? Although it's made out of mass everywhere, there's a certain point, if you keep your hand there, you can balance the full system. You can balance the full system. Okay? You can balance the full system. How? Because at the end of the day, all this force will get together and create a resultant. Okay? The weight of the whole object will be acting at a certain point. That is the resultant force. That is the point of action. This is how we find the point of action of that resultant force. Okay? See, what I just got is the point of action of the resultant weight, which means the point where the whole weight acts. That we call the center of gravity of an object. Okay? That we call the center of gravity of an object. Clear? Clear? That is the center of gravity of an object. Clear? Okay? That means the whole weight acts at that point. Clear? Whole weight acts at that point. Clear? Got the idea? That is the center of gravity concept. Clear? So, like with the same concept, you can continue for center of gravity questions too. Okay? You can continue to center of gravity questions too. So, here, if I do the next one, quite simple now. But what they're asking is find the distance x from the point A to the line of action of the resultant force of the following system. So in question 2, you have point A, like this, and you have 10 newtons acting here, 10 newtons acting here, 20 newtons acting here, 20 newtons acting here. This is 5. this is 5, this is 10, this is 5, and this is 10, this is 10, then the resultant is acting at a distance of x. So again, the thing is quite simple. Resultant is 10 plus 20, 30, right? Resultant is 10 plus 20. Resultant is 10 plus 20 gives you 30 newtons. Okay. Resultant is 30 newtons. Okay. Then what is the point of action to the resultant? This is the point of action of the resultant, right? So principle of moment, moment by each force around A in this direction, moment of each force, that means 10 newtons into 5 plus 20 newtons into 10 equals R. R means 30 equals R. R means 30 into X. 30 into X. R into X. Clear? 30 into X. Clear? Then what would you get here? X equals 50 plus 200 over 30. Clear? 50 plus 200 over 30. Clear? That's how we get the point of action of the resultant force. Clear? Okay. Point of action of the resultant force. So for online students, you will get your papers marked and we'll send it to you through email. Okay. We'll send that. Okay. So at what time do we end this class? 7:30, right? Yes. Sorry? Really? Okay. So, but we have time today, like no people in the class. Okay. So, but anyways, I'm not going to move into the center of gravity part, but the final idea is this is the whole concept of center of gravity too. Okay. Center of gravity is not a new concept. It is just the point using principle of moment. What we find is resultant force, distance to the resultant force. And when force is weight, center of gravity is the resultant weight, right? Where the resultant weight acts. Clear? This is made out of millions of particles. Each particle has its own weight. Altogether, when you take it as a whole, okay? Altogether, when you take it as a whole, the whole weight is acting at a certain point. We call that the center of gravity. Clear? We call that the center of gravity. Clear? Okay. So then I'll stop it here, but you can try exercise 8 too. You can try exercise 7 and exercise 8. Okay. I'll start the paper discussion at 7:40. Okay. I'll start the paper discussion at 7:40. Oh, let's make it 7:40 within 10 minutes. Okay. I'll start the paper discussion for today at 7:40. And today's mark list, again, since a lot of students are online, people are marking the papers online, we'll provide the mark list in the WhatsApp group. Okay. Okay, please send me the question numbers you need me to discuss. Please send the question numbers. Mark list will be provided. Mark list will be provided, and I mean, I didn't take the mark list and all very serious today because we were not able to do the paper properly because we cancelled the physical one. But mark list will be provided in the group, and the papers are as usual available in the group. Model paper 52, right? Model paper 52. And if any physical class student need the tutes, they can get the tutes, get the paper from there. And put in the Zoom chat the questions you need me to discuss. Question numbers you need me to discuss. Any important numbers to start with? Okay, then let's start with question 2. Let's start with question 2. Some answers may change when I do the discussion. We'll see. Okay, so the quantities have the same dimensions as the, sorry, question 2, model paper 52, model paper 52, question 2. The measurement that cannot be taken using a traveling microscope in the lab is external diameter of a calorimeter, side length of a cube of about 5 centimeter, internal diameter of a calorimeter, internal height of a calorimeter, internal diameter of a rubber tube. Isn't the answer given is 4? Yes, right? Yes, right? Okay. Internal height of a calorimeter, right? Impossible. Why? You ask question 2, right? Yeah. Internal height of a calorimeter is impossible. Why? Fourth answer. It is impossible. Why? How can you measure a height? Why? Calorimeters. But there may be a small issue. Calorimeters are, you haven't heard this term before, right? That may have been the issue. Calorimeter is just a bin, okay? Just a copper bin. Copper bin that we use for heat practicals. We put something here. We put something here. We put another thing here. We mix some stuff. We use a Bunsen burner to heat this up. We do different heat practicals. It is just a copper bin, okay? That we, copper or aluminium or a metal bin that we use to do heat practicals. So how can you measure the depth of something using the traveling microscope? Okay? I mean, you can't measure the depth of a calorimeter using a traveling microscope because, I mean, how can you focus to the bottom? And how can you focus to the top? There's no lid. So there's no way of focusing here and here, right? There's no way of focusing here and here, right? In all other scenarios, it's possible. Side length of a cube, yes. Why? You have a cube like this. You focus here. You focus here and here, right? You focus here and here, right? Clear? Okay. And about a calorimeter, you focus here and here. See? But this is impossible. But there are some, I mean, if they ask in a structured question, maybe, if definitely you will get some structured questions in the term test paper from like measuring instruments too, okay? So in structured paper, if they ask how to find the depth of this using a traveling microscope, what can you tell? Any method in mind? If they ask you to somehow, you have given the question would look like, you have given a traveling microscope, okay? You have to measure the depth of it using the traveling microscope. How can you do that? If you like, you can do something like this, okay? I mean, just a suggestion, just to make sure like you think creative for the structured paper, okay? You can like, if you like, you can like Draw a small white cross here and first focus the traveling microscope there. Okay. Then if you like, you can fill water entirely. You can fill water entirely. Okay. And place something here, floating. Place something floating here. And you focus to the floating object. You first focus the traveling microscope here. You first focus the traveling microscope here to the bottom, clear? Then you focus the traveling microscope to the top, clear? You first focus the traveling microscope to the bottom, then you focus the traveling microscope to the top. Then you can, like when you take this up, the readings may change and you get the reading, see? You have that option, okay? I mean, this is not anything, this is not something theoretical. If they ask you in a practical question, they are not giving you a vernier caliper. You have given a traveling microscope, somehow find the depth. If the question looks like that, you can come up with options like this, okay? Especially in your term test structured paper, if they ask you like practical questions, don't think so extremely serious methods, come up with very practical solutions like this, okay? In the structured paper, you don't have to like think a lot of theoretical stuff to be challenging, not like that, okay? You just think the simplest possible thing in the structured paper, okay? And give that as the answer. And the other one asked was question 3. Let's go to question 3. Question 3. Question 3. According to the measurement taken using a certain instrument, the diameter of a capillary tube is 1.25 millimeter. If it is expressed to the correct number of significant figures, the percentage error is. According to the measurement taken using a certain instrument, the diameter of a capillary tube is 1.25 millimeters. Diameter of a capillary tube is 1.25 millimeters. If it is expressed to the correct number of significant figures, the percentage error is. Okay, the idea is this. There are two possible answers here, but I hope there's only like we can come up with a better answer. The idea is the measurement is 1.25 millimeters. What is the rule for writing a measurement? What is the rule for writing a measurement? Rule for writing a measurement is, okay. Rule for writing a measurement is you should write the measurement in a way that it represents the least count of the instrument, right? That means the least count can go up to this decimal point, clear? Least count can go up to this decimal point, clear? So most probably the least count would be 0.01 millimeters, right? Most probably the least count will be 0.01 millimeters, clear? Most probably it will be 0.01 millimeters, okay? That means, okay, that means now you know how to get the percentage error, right? That's how we find the least count. So what is the percentage error then? They're asking for the percentage error. Percentage error is 0.01 over 1.25 into 100%. Clear? Clear? What is the answer? Do we have an answer here when we solve this? 0.01 over 1.25 into 100. 0.8, yes, there's an answer, right? 0.8%. It's not given. It's not the given answer. Diameter of a capillary tube 1.25. 0.01, no error there. Percentage error is 0.01 over 1.25 into 100%. Yep, it should be 0.8%. Nothing wrong here. Yeah, should be corrected. The answer should be corrected. It should be 0.8%. It is not the given answer, right? It's not the given answer, right? Well, question 3 answer should change to 0.8%. Question 3 answer should change to 0.8%. Let's release online marks again if required. It's 0.8%. Let's go to question 7. Let's go to question 7. Question 7. A vehicle moves north with a speed 30. After severe collision with another vehicle, it rebounds to the east with speed of 40. Which of the following best represents the change in velocity of the object? So, first of all, question 7. A vehicle is moving north with a speed of 30. North with a speed of 30. After a collision, rebounds to east. East means this direction, right? Or this? This, right? Yeah. East is this. It rebounds east with a speed of 40. With a speed of 40. Which of the following is best represent the change in velocity? What is the change in velocity? Delta V. What is the change in velocity? Delta V. Final velocity minus initial velocity, right? Change in velocity is final velocity minus initial velocity, right? Clear? Change in velocity is final velocity minus initial velocity, right? So what is the final velocity? 40 in this direction minus initial velocity is 30 upward. Clear? And minus will reverse the direction. Minus will reverse the direction. Then you will get plus 30 downward, then the resultant you get by drawing a triangle of vectors, right? Resultant you get by drawing a triangle of vectors 40, 30, then the resultant would be 50, right? Resultant would be 50. Clear? Got the idea? Okay. 8. Let's go to question 8 too. Eight. An object is projected such that its maximum horizontal range is 400 meters. Considering the projection point as the origin, the coordinates of the point where the velocity is minimum is. Velocity is minimum. Isn't that the highest point? Yes, right? That means this is the idea. Question 8. There's a projectile like this. It goes like this. It goes like this. Object is projected such that its maximum horizontal range is 400 meters. Its maximum horizontal range is 400 meters. That means its horizontal range is 400 meters, right? Okay. I think this is the idea then. Maximum range is 400 means I think the angle will be 45 if required, right? I think that's what they are trying to tell. Range is 400. Range is 400. And at the moment, the projectile angle is 45. How do we find that the projectile angle is 45? Because how do we find that the projectile angle is 45? Because like here, um, they are talking about the maximum range, right? That word was given with that objective, right? That word was given with that objective. So if that is the case, what is the equation for range? Can someone remember what is the equation for range? 2u squared, if I'm correct, sine theta cos theta over g, right? Range is 2u squared sine theta cos theta over g, right? What is the maximum height? Now they are asking the coordinates or the location of the minimum velocity, right? We definitely know that the minimum velocity is at the highest point, right? Why? Why? You always have a horizontal component and a vertical component. In a projectile, you always have a horizontal component and a vertical component. Clear? Horizontal component never changes. Horizontal component never changes. And you always have to add the vertical component to that, which will give you a higher resultant. But only at the highest point, the vertical velocity is 0, right? Only at the highest point, the vertical velocity is 0, right? So you will get the lowest resultant at the highest point, right? Clear? You will get the lowest resultant at the highest point. Clear? So definitely the x coordinate of the highest point is 200, right? This is symmetric. X coordinate of the highest point is definitely 200, right? So how many answers do we have with the x coordinate of 200? Two answers, right? So we have to find the maximum height. We have to find the maximum height, right? This is the case. If I were you, usually after figuring this out, I would go with 200 and 100. Definitely I know that the x coordinate of the highest point is 200. 200. And the y coordinate I have to find, right? Height I have to find. Y coordinate is the maximum height of this projectile, right? So usually in a scenario like this, range is definitely, but it is half of the range. I can't predict, right? Can't decide 200 to 100. I thought that the range is 400. No, it's not easy to decide, right? I can assume whether the height will be 200 or less. Yeah. Okay, yeah. Still I can go with 100. Still I'm gonna go with 100. I won't do any calculations. I will choose the answer 200, 100, okay? I will choose the answer 200, 100. Is this the answer given? Yep. Yeah? Okay. Why? What is the reason? I mean, you know that the projectile bends, right? You know that a projectile bends. This angle is 45. This angle is 45. If I draw a straight line like this, okay, clear? This angle is 45. Okay. If I draw a straight line like this, if I draw a straight line like this, if this is 200, this will be 200, right? If I draw a straight line this like this, if this is 200, this will be 200, right? Why? Tan 45 is 1. Tan 45 is 1, right? That means 200 over 200 gives you 1. Clear? Tan 45 is 1. 200 over 200. Clear? In that case, okay. In that case, tan 45 is 1. So if this is 200, this will be 200, right? So definitely a projectile don't go like this, it bends, right? It bends. So the final answer should be something smaller than 200. So 200, 200 is not the answer, 200, 100 is the answer, right? I mean, although it takes some time for me to explain this, when you start thinking like this, I mean, for me, it would take only uh, 3 seconds to get the answer, right? It will take only 3 seconds to get the answer. Yes, even to explain a short method, it takes time. Because in the class, we have to explain how did we think that. But when you think like that, it takes a very small time for you to think, okay? Because you have to handle 25 MCQs in 1 hour in term test usually. So you can't afford to do calculations for everything. You have to think smart, okay? So, like, why? I mean, if I forget about teaching, if I think, okay, I know the minimum velocity will be at the middle. So it is 200. This is 45 degrees. So the height should be smaller than 45 degrees, right? Okay. Otherwise, what is the method? Otherwise, what is the method? You have R. What is the equation for H? As I remember, U squared sine squared theta over 2G, right? Yeah. So you put sine 45 G, R 400, R 400 and find U. You put that U here and calculate and find H. Okay. I don't have to go through that trouble because there's only one possible answer, right? X coordinate is definitely 200 and there's only one possible answer. Clear? Okay. I don't have to go through that, all of that trouble. Okay. Okay. Next. Let's see what online students ask. Let's try question 14. Let's try question 14. Let's try question 14. In the system shown below, the pulley is light. What is the acceleration of 1 kilogram mass? Here you have 4 kilograms. Here you have 4 kilograms, which means 40 newtons. Which means 40 newtons. Here you have 1 kilograms, that means 10 newtons. 40 newtons and 10 newtons. Clear? You have 40 newtons and 10 newtons. Acceleration of 1 kilogram mass. So this is the idea. This is the idea. You have the same tension everywhere. Okay. You have the same tension everywhere. You have the same tension everywhere. Okay. Have the same tension. If you consider this, okay. Now, first of all, they are asking the acceleration of 1 kilogram mass. Let's think that the acceleration of 1 kilogram mass is A. If the acceleration of 1 kilogram mass is A, what is the acceleration of this guy? It should be A over 2, right? Acceleration of this guy should be A over 2, right? I hope. Why? Why? It's like this. See, this is this pulley. Okay. Then it goes up. It goes up like this. Then this is the next one. And it is like this. Okay. Now, if this pulley is here, and if it goes until here, if it goes up until here, if it moves a distance of x, okay, if it moves a distance of x upward, okay, what will be the length of this string? How much distance will it travel? Assume that this pulley goes a distance of x. See, this pulley goes a distance of x. Clear? String receives 2x. Why? When you go x height up, string, x distance of string gets freed from this side, and another x distance length of string gets freed from this side, right? When this moves a distance of x, a length of x of the string gets freed at this side, and another length of x gets freed from this side, right? That means a overall length of 2x become free, right? Overall length of 2x become free, right? Here, when it goes up, an overall length of x plus x, 2x gets free, right? Clear? That means the string receives additional length of 2x, right? That means this will move down a distance of 2x. Clear? That means when this pulley moves a distance of x, when this pulley moves a distance of x, this moves a distance of 2x. Clear? So if the velocity of this is v, this will be 2v. Why? You divide this by time. You divide the displacement by time and get the velocity. If you divide this again by time, you get acceleration here and 2a here. Clear? A here and 2a here. Clear? You get a here and 2a here. Clear? Got the idea? So if the acceleration of this one is a, acceleration of this one will be 2a. But in my scenario, I consider the acceleration of this as a. So the acceleration of this one would be a over 2. When this is 2a, this is a. So when this is a, this will be a over 2, right? So then Then now I have all the information required. I'll apply F equals ma to this guy. I'll apply F equals ma to this guy. The weight is 10 downward. Weight is 10, right? Here, the weight is 10, clear? Weight of this one is 10. And the tension upward is T. Tension upward is T. 10 minus T, clear? 10 minus T equals, what is the mass of this one? 1 kilogram. Mass of this one is 1 kilogram. Acceleration is A. Acceleration is A. Clear? Clear? 10 minus T equals 1A. Clear? Then about this guy. You have 2 into T upwards. I'll apply F equals ma to that guy upward. You have 2 into T upward. 2 into T upward. Downward 40. Downward 40. Clear? 2 into T minus 40. What is the overall mass here? 4 kilograms, and the acceleration is A over 2. Acceleration is A over 2. Clear? Whole target is to find A. So what I can do is this 2 and this one will cancel out. You are left with 2. Then you divide this again by 2. So T minus 40 equals A. Clear? You divide this by 2. T minus 20. Sorry. You divide this by 2 again. So you get T minus 20 equals A. Clear? Divide this by 2. T minus 20 equals A. Clear? Then you have 10 minus T. 10 minus T again equals A. 10 minus T equals A. T minus 20 equals A. Clear? So what you do is you add these two. Clear? You add these two. What happens when you add these two? T minus 20 plus 10 minus T equals 2A. T cancels out. T cancels out. Okay? T cancels out. You get minus 10. Minus 10 equals 2A, which gives you A equals minus 5 meters per second square. What is the meaning of minus 5 meters per second square? I thought that this will go down, but actually it goes up. You don't have to worry sometimes when you are marking the direction, okay? Because if the direction is opposite, you will get a negative answer, okay? You don't have to worry about that, clear? If the direction is opposite, you will get a negative answer anyways, clear? So don't have to worry about that a lot. Question 15 is a bit like not difficult, actually bit difficult due to since you haven't done coplanar forces yet. I think it will be a bit hard because you haven't done coplanar forces. It's an equilibrium question, right? It's an equilibrium question, as I say. So one of the problems in equilibrium questions is you have to use your O-level knowledge. Okay, you have to use your O-level knowledge. That is the problem. See whether can I explain it using the things that you already know. Yeah. I'll try to provide that explanation online, and most probably the week after next week, because you can do that. Okay, if you have done really, you have worked really well in all levels, yes, you'll be able to handle that. Otherwise, it is an entirely equilibrium question. So the concepts related to equilibrium, moments and all, you will learn now only. Okay, this week and next week you will learn about moments properly. Then you will be able to handle this. You have to take moments around different points and see how to make sure that the system is in equilibrium and the moments are zero. If the moments are not zero, some sticks here will rotate. If the linear forces are not zero, some sticks will move. Okay, so you have to balance everything. You have to confirm that the moments are zero and the resultant forces are zero, right? Clear? I'll do that later then. Question 15. Yeah, let's go to 9th and 10th then. Question 9. An object is released from rest on an inclined plane, inclined at 45 degrees to the horizontal. If the time taken to slide a certain distance down a smooth plane is twice the time taken to slide the same distance down on a rough plane with friction, the coefficient of dynamic friction is. So they are talking about time. So this is the idea. Something slides down without friction, right? Something slides down without friction. That means you have mg down. This angle is theta. So this component will be mg sine theta. This component will be mg sine theta. Okay. So I'll apply like, anyways, I know the acceleration in this direction, right? If it is a frictionless plane, I know that the acceleration in this direction is g sine theta, right? So if the length is L, I can write S equals ut plus half at squared downward. The length is L. Length is L. Starting velocity 0, half. Here I get g sine theta t squared, right? I'll consider that time as t1. Okay, t1. Then the next scenario, theta, you have mg downwards. You have mg downwards. If this is theta, as we know, this is 90 minus theta. So this is again theta, right? This is theta. So you have two components, right? mg sine theta in this direction, mg cos theta in this direction, right? You have mg sine theta in this direction and mg cos theta in this direction, right? Clear? Since it is not going to move in this direction, normal reaction R, since it's not going to move in this direction, normal reaction R will be equal to mg cos theta, right? Normal reaction R will be equal to mg cos theta, clear? R will be equal to mg cos theta, clear? R will be equal to mg cos theta, clear? Then what will be the friction here? What will be the friction here if it is sliding? When something is sliding, the friction you have is dynamic friction, right? When something is sliding, the friction you have is dynamic friction, right? Dynamic friction is equal to usually mu r, right? Dynamic friction equals mu r, right? So you get mu r means mg cos theta, clear? Mu r means mg cos theta, right? Clear? So when you apply F equals ma, downward you will get, downward you have mg sin theta, and upward you have friction now. Clear? Downward forces mg sin theta, upward mu mg cos theta, friction. Clear? When it is sliding, you have mu r friction, right? You have mu r friction, which means mu mg cos theta. Clear? Minus mu mg cos theta. Clear? Minus mu mg cos theta. Clear? mg sin theta minus mu mg cos theta equals ma. Equals ma. That's how you get the acceleration, right? So the acceleration would be, when you solve this, m cancels out. Acceleration will be, I'll take g out. Then you will get sin theta minus mu cos theta, right? I took g out, clear? Sin theta minus mu cos theta, clear? Then uh, then uh, then uh, like I can, now I know the acceleration, so I can find the time, right? Downward s equals ut plus half at squared, clear? So again the length is same length, right? L. Starting velocity 0. Starting velocity 0 plus half. What is the downward acceleration? This, right? This is the downward acceleration. G sin theta minus mu cos theta, clear? Half acceleration is g sin theta minus mu cos theta, half a t squared, right? Here the time will be t2, clear? Clear? So now you have the answer. Why? The question is, time is twice the time taken to slide the same distance on a rough plane with friction. I think it should be inverted, right? The idea, anyways, you can understand, right? You will move faster in a frictionless plane. You will move slowly in a plane with a friction, right? So the meaning is, it takes more time here, right? It takes more time here. it takes twice the time here, right? If you move here in t1 time, that t2 is 2t1, right? That is 2t1. So half g sine theta minus mu cos theta. T2 is 2 into t1, right? T2 is 2 into t1, clear? T2 is 2 into t1, clear? 2 into t1 squared, clear? So now this L and that L is equal, okay? This L and that L is equal. Then you will get this L is half g sine theta t1 squared. There you get half g sine theta minus mu cos theta 2t1 squared. Clear? Clear? Then half g and half g will cancel out. T1 squared and T1 squared will cancel out. You have sine, what is the angle? 45, right? Sine 45 equals here sine 45 minus mu cos 45 into 2 squared means 4, right? Here you have 2 squared, that means 4. Clear? 2 squared is 4. Then you get sine 45 is 1 over root 2. Cos 45 is also 1 over root 2, right? All are 1 over root 2. Clear? Sine 45 is 1 over root 2. Cos 45 is 1 over root 2. So you can divide the whole equation by that too. You have 1 here. Here 1 minus mu. 1 minus mu into 4. Clear? So when you solve this, you will get mu equals 1 minus 1 over 4, which means 3 over 4. Clear? Clear? I take 1 over 4 here, 1 here, you bring 1 over 4 there. Mu equals 1 minus 1 over 4 equals 3 over 4. Clear? Okay. This is the last part of the calculation. Clear? You find the acceleration, you find the time, you find the acceleration, you find the time. You create the relationship between them. Clear? Now, since we have done work power energy now, you have another method too. Okay, sometimes you may be able to use work power energy too in some equations. Let's go to question 10. You can write things later. Recording will be available anyways, and also you'll be able to find the review in the group too after the discussion. So question 10, but I'll give you 1 or 2 minutes if you were writing. Okay. Question 10. Question 10. An object of mass m is placed at rest at point A at a height h above the ground. The inclined plane below has a horizontal section of AB and a strip BC with a coefficient of friction mu. The plane is inclined at an angle of theta to the horizontal. The velocity of the object at C is. BC, there's a friction, right? Since we have done work power energy now, let's use that, right? It will be far more convenient here. Why? There are two paths. Half of the path you have friction, right? Half of the path you have friction, right? Not half actually. Simple H and this is capital H, right? You know in this region, this region you have the friction, right? This region you have a friction, right? Clear? So in this region, your weight is mg. In this region, the weight will be mg. Weight will be mg. This angle is theta. This angle is theta. This is theta as usual. If this is theta, 90 minus theta, then this is theta. Then this is mg cos theta. Clear? This is mg cos theta. Then the normal reaction will be R, which is equal to the same mg cos theta. Normal reaction is R, which is equal to the same mg cos theta. Then since it is slipping, you will have the dynamic friction Fd. You will have the dynamic friction Fd, which is again equal to mu R. Dynamic friction equals mu R, clear? Which means mu mg cos theta, clear? Mu R and R will be mg cos theta, mu mg cos theta, clear? Mu mg cos theta. And what is the length of this path? If this is h, if this part is h, and if this angle is theta, what is this length x? I can write sine theta equals h over x, clear? Sine theta equals h over x, clear? Sine theta equals h over x, which means x equals h over sine theta, clear? X equals h over sine theta, clear? X equals h over sine theta. They have given us what? They have given it as R. So we have to use Pythagoras, right? Sorry, I didn't see that. They have given this distance as R, right? They have given me this distance as R, right? So x squared equals h squared plus R squared then. So x equals square root h squared plus R squared, clear? Now since you know work power energy now, everyone watch the work power energy recording if you missed that session, okay? Definitely watch that, because even though you are not getting it for your term test, your life will be really easy, okay? Your life will be really easy if you know that, okay? Clear? So you will get like this. This is a block of M. When it reaches to the bottom, it release an energy equal to mgh, right? It release a potential energy equal to mgh, right? Potential energy decreased by mgh, clear? Mg capital H, clear? Potential energy decreased by amount of mgh, clear? Potential energy decreased by mgh. Clear? Your potential, while your potential energy goes down by mgh, okay, what will happen is that mgh will be converted into two things at the bottom. What are they? That lost potential energy will be converted into a certain amount of kinetic energy, half mv squared, certain amount of kinetic energy, plus work done against the friction, Fx, work done against the friction. You get mgh, but you use that against friction, remaining part will be the kinetic energy. Clear? Remaining part will be the kinetic energy. Clear? Got the idea? So you get here, from here to here, you get, from here to here, you get work done as Fx. Clear? Work done as Fx. So what is F? Here friction. Mu mg cos theta. What is the distance from here to here? Square root h squared plus r squared. You solve this and you get v, right? You solve this and you get v. You divide the whole thing by m. You take everything to this side and multiply by 2. Multiply by 2. That means you have here v over 2 remaining. Here you will have gh plus gh minus, you take this one here, gh minus, right? Minus mu g cos theta square root h squared plus r squared. Clear? gh minus mu g cos theta h squared plus r squared. Clear? Then you will get the velocity as, you multiply by 2, 2gh minus 2 mu g cos theta square root h squared plus r squared, then square root. Clear? Got the idea? We have the answer, right? Yeah. Fifth one, right? Yeah. Yeah. So that is the idea behind this question. Clear? Okay. So I'll stop the session at this point for today. Next Monday and Tuesday also you'll have some sessions. Okay, I'll let you know. Tomorrow's plan, I'll let you know. I'll now think and discuss and think tomorrow's plans and let you know. Everything will be informed in the group. I'll let you know whether I'm doing an online thing tomorrow, a physical thing. Or anyways, if we are doing physical, we anyway stream online. Okay, I'll let you know about tomorrow's plan. Okay. Yep. Thank you. Thank you for joining. Marks we have, right? Yeah. So the marks for today. Yeah, we have 11 marks of Vindi Akisha, Dahamsa Gunasekara, Nuha, Senuja Anusara, Chamatka Vardana, Sadisa Fernando, Senuki Abbe Gunavardana, Senadi Vijaymuning, Tenuki Bosirini. The 12 marks, K. Kritish, Sharon Rodrigo, Shaneli Jayavardana. 13 marks, Vidurshikan, Dinara Tuljan, Pasandu, Senadire. Then 14 marks, Chenita Matata. Yeah. So yeah, let's meet next week then. Thank you.